Hello friends, welcome to the series tutorials on solving the quadratic equations using paper folding techniques and bicycle driving analogy. So in this video we are going to talk how to solve the quadratic equations in this form where the constant term is negative and the quadratic equation has two distinct real roots, meaning b square minus 4ac is greater than 0. So let's directly get started with an example. I'll take the same example that we discussed in the previous video, but I only change the sign of this constant term to be negative. So first take a graph paper, then draw an arbitrary horizontal line almost at the center of the paper. Mark a point 1 units below the line and imagine playing a bicycle. If you have seen the previous video, you might have known the steerings or the handle represents the signs and the distance is represented by the coefficients. So we trace out the path of this quadratic equation by using the bicycle. So at first we move a distance of 3 units in the bicycle like this. Then as the plus sign says, rotate the cycle as shown by the arrow. So this arrow is showing the direction in this way, so rotate this cycle in this direction and then move 8 units. Then comes the turn of the negative sign over here. Negative sign says that flip the arrow and rotate as per the direction, so we are going to flip this arrow like this and rotate in that direction. Then we are going to move 5 units up in the bicycle. At last what we do is we trace the path back to the starting place where we originated. In the next step we cut down the quadrilateral as shown by this dotted line. So we'll get this paper. Then what we do is we fold the paper as instructed. So I'm going to use a software called GeoGebra to fold the paper. So this is the paper that we have cut. Now in the first step, fold the paper in half in such a way that the ending point and the starting point coincide. Saying the starting point, this is the point where we have started riding the bicycle, and this is the ending point. So what I will do is I will fold this paper in such a way that this point just coincides with this point. Then it will leave a crease in this paper. Then we will again unfold this paper like this. So this will leave a crease like this and a point of intersection between this line and this crease. In the next step, bring the starting and the ending points to touch the blue line as shown and mark the points. Now in the initial condition we only had this blue line. Now we are going to extend this blue line to reach this point, and also we are going to extend this blue line to reach to the next end. Then I will fold this point in such a way that it just touches the blue line, and I'm going to shift this point such that the back end of the paper just touches the midline or the midpoint, and the top point touches this blue line. Then we are going to mark this point and again unfold the paper like this. Similarly, we are going to bring this point to this blue line in the similar way. Let's fold this paper, bring this in the blue line in such a way that the back part of this paper will just touch the midpoint. You can use the transparent paper to make your work easier, Or what you can do is you can trace the lines both on the front side and the back side of the paper to make this folding easy. So after doing this, we will also mark a point over here like this, and we will again unfold the paper. So we will get these 2 points as a result. I have used more precise graph paper so that it will be easier to measure the length. Now we join the points found from paper folding to the starting point. Since this is the starting point, we join the lines like this. Then we measure the 2 distances, and this will be the answer. So we measure from this point to this point, and which is, you can see, which is 1, 2, 3 and almost 3.2, and we're going to measure another distance which is almost 0.5. One thing to remember is that this length 3.2 is on the left side of this starting line, so 3.2 will be in negative, whereas this 0.5 length is in the right direction of this starting line, so this will be in positive. So the roots are minus 3.2 and 0.5 respectively. Let's compare the 2 results. We get the roots of the quadratic equation to be minus 3.2 and 0.5 from paper folding, and from algebra we get the result as this irrational number. So if you have idle folding and idle construction, which is actually hypothetical only, we will give the accurate result. Now let's make a slight change in the previous question. I will change the sign of this B to make it negative, and we'll take the same example but by changing the sign of B. So let's first take a graph paper, draw an arbitrary horizontal line almost at the center of the paper, mark a point 1 units below the line, and imagine placing a bicycle like this. Then move 3 units in the bicycle. Then as the negative sign flips the arrow like this, and then rotate as per the direction. Then move 8 units. Again the turn comes with negative sign, so that will flip this arrow, and then rotate this bicycle. Then move 5 units in the direction of the bicycle. At last we trace back our steps to the original place where we have started. Then we cut the quadrilateral as shown by the dashed lines. Then we fold the paper as instructed. So in the first step, what we do is we fold the paper in half in such a way that the ending point and the starting point coincides. So this is the starting point and this is the ending point. So I will just flip this paper so that these 2 points coincide, which will make a crease in this paper like this. Then I'll unfold the paper like this. Then we bring the starting and ending points to touch the blue line and mark the points. First, I'll try to fold this point in such a way that I'll try to touch the blue line, and also try to make sure that the back part of this paper is just touching this point, and I will mark this point over here. Then I will again unfold the paper. The same process I do with the other end also. I flip the paper, make sure it touches the blue line, and then also make sure that the back part of the paper just touches the midpoint. As we have already talked, you can use the transparent paper, or you can trace the lines on the front and the back side of the paper so that it will become easier for you to fold and find the exact points. Here also we mark another point here and again unfold the paper. So we have got these 2 points. So this is the precise graph paper, so we have already got the 2 points from folding. Then we will join these 2 points from the starting point. Then we will measure the 2 distances, which will give the answer as we have already talked. So distance from this point to this point is around 3.2 and the distance from here to here is around 0.5. As you can see, these 2 distances are separated by this red line. So 3.2 is on the right side, hence it will be positive, and the length 0.2 is on the left side of this line, so it will be negative. So our answers are 3.2 and minus 0.5. So we can compare the algebraic results and what we gave from paper folding. So this is all about solving the quadratic equations having real roots. So in the next video we'll try to cover how to solve the quadratic equations having complex roots. Till then, thanks for watching.